Hello guys, this is Mike from McProgramming.org, and this is going to be another video in the algorithm sorting section and I'm just happen to be coding it in Java, but the pseudo code that you can get from this would be very easy to extract from this, and you can apply it to whatever language you need. So I'm going to do selection sort today, and it's similar to bubble sort because they're both n squared running time algorithms, and I'll go over how to find the time complexity of an algorithm in the near future, but for now I'm just doing the coding of these. Another popular n squared sorting algorithm will be insertion sort, which I'll go over next, and then we'll move on to faster running times, which would be like n log n or big O n and so on. So let's write this selection sort. And before I start the selection sort, the idea is to start here at the very beginning of the array, and we're going to go through every element and find the smallest element, and then we're going to send that to the front, and we're going to say that this part has been sorted and everything will move on and start looking from here. So let me code that up, and then I'll go through and explain it again. So we're going to create a static method, public static, and the return type I'm going to say integer array, and let's just call this sort. You can call it selection sort if you want. And we need to pass it this numbers array. And this is a small array actually, so the running time plays a big role when you have an array or some type of data structure that has tens of thousands, hundreds of thousands, millions of elements. But this one, n squared, will do just fine with 5 elements. But let's get started. We're going to have 2 for loops, and the first for loop is going to take care of this I, which is where we're going to start at. So for int I equals 0, we're going to run while I is less than the array.length minus 1, and we're going to increment I every time. Alright, and now what we need to do is to keep track of what the smallest element in this array is. We're going to keep track of the index of that smallest element. So let's create a variable int, and we'll just call it min index. Could think of something shorter, but that'll do. So min index, and we're going to set that to I, and now we're going to write another for loop that loops through each of the elements in the array, and it's going to do a comparison of 2 elements that are next to each other every time and find the min index. So let's say for int j equals I plus 1, and we're going to run this while j, lowercase j, is less than a dot length. Okay, make sure that this one is a dot length minus 1, and this one is a dot length, and j plus plus. Okay, so now inside of this loop, we are going to compare the 2 elements that are next to each other. So it's going to be an if statement, and we're going to say if a with the jth element, if that is less than a of min index, well, we need to set a new min index. So let's say min index equals j. Alright, and now outside of, make sure it's outside of this for loop, but within this for loop you are going to want to do a swap, and that is pretty simple. We have a temp integer right here that will hold the value. If you watch my last video, you'll understand a little bit, but I'll go over it again in a second. So we're going to create a new int temp equals a min index. Okay, so we are throwing the element with that min index into this temporary placeholder right there, and then we are going to say a min index equals a of I, and set a the ith index equal to that temp. Alright, there we go. And we need to return an integer array, and that's why we have this error right here. See, it says add return statement. So below all of this, make sure you're outside of your for loop. We're going to say return a, because a is that integer array. And let's run that real quick. Let's say sort, and we're passing it an array, so we can pass in this numbers right here, numbers, right? And take note that if you did instantiate this object right here, or this class, and made an object out of it, we would have to have the object name dot sort, so whatever you called it. But since it's a static method and it's of the same class, we don't, and we can just call the method. So it's a little prettier on the eyes just for this example. And then I have a print, let's see, yeah, print array method that just prints it out. Make sure that it is in the correct order. So print array, and we're going to pass in the same array name because that's the one we just sorted. It'd be nice to see if it worked. So let's run that. Hopefully it works. So we started with 10, 5, 3, 7, 2, and our output is 2, 3, 5, 7, 10. So it looks like it works. Now let's explain it. Okay, so if you notice, I starts at 0, index 0. This right here is our array that we started off with. These are our indexes of the array, indices I guess you'd call it. So 0, 1, 2, 3, 4. And we have an I that represents this outer loop right here. And we have a J that represents our inner loop. Okay, and then this right here, I'm going to start putting an X that will point to the sorted array so far. So I starts at 0 and min index equals I. So now that we have our min index right here that we can visually see how we're storing it, let's run through this. We're going to say that I is 0, so min index is 0. And now we're going to jump into this loop right here. Okay, so j is I plus 1. And now we are going to compare a of j, which would be right here, this 5, versus a of the min index, which is here. So is a of j, this, less than this? Yes, it is. So our min index we're going to set to 1, and j increases. J. Alright, and now we are going to say, is a of j less than a of min index, which would be this right here, and yes, indeed it is. So we can increase this here, and we will put, that was index 2. So now we are going to compare, is a of j, which is 7, less than a of min index, which is 3. No, it's not, so we'll ignore that step, and we'll come here where j, a of j is 2, and is that less than a of min index, which is 3? Yes, it is. So our min index will be 4. And what we do now, since we went through this loop, we come down here and we set the temp equal to a of min index, which is 2, and then we set a of min index equal to a of I. So this right here will get 10, and right here will become a 2 on this next one. So AI equals this temp, so 2. Alright, so now I gets incremented by 1. So we're going to start off here, and j goes to I plus 1, which is here. And let's just put a big ol' X right there. And this is, well, this column right here is our sorted array. So now we would just go through the motion and do this again. And we would keep doing this, and 3 would come out to be the min, or 2 would be the min index, which would represent that 3 in the element, and that would become here, and the 5, and then so on. So that is how this works, and remember that it's big O and squared is the running time, at worst case at least, and it shouldn't matter too much if it's a small array, but it will matter once you get bigger arrays. So please join me as I will continue to make these algorithm and sorting videos, and this is in Java, but a sorting algorithm is a sorting algorithm in any language, so I'm sure if you can go through the logic, you can code it in whatever language you want. Thank you guys for watching, and please subscribe below.